Hello everyone. Here we start from the basics of networking. So before starting the session, if you have not subscribed the channel till now, then subscribe now by pressing the red subscribe button below and press the bell icon for notification for upcoming videos. Before we start networking, let's see how data flows into a network. As we know that data flows in the form of zeros and one. So if we write, so if we want to transfer 38 into a network, it will be sent in the form of, so it will be transferred in the form of binary 10 0 1 1 0. Here we see that here every 4 bit is a nibble. So what is a nibble? So what is nibble? Here in computer networking, nibble is a 4-bit aggression or half of of an octet. So here numbers divided into 4 types as a decimal, binary, octal, and hexadecimal, with the decimal as base 10, binary as base 2, octal base 8, and hexadecimal base 16. So let's first we see that how to convert a number to binary. So let's convert 65 decimal into binary. So as we know that for decimal its base number is 10, and for binary its base number is 2. So if we want to convert a decimal number to binary, we have to divide it by 2. We get as 32, and its remainder is 1. Now again, if we divide 32 by 2, its decimal is 0. So on dividing 32 by 2, we got as 16 with the remainder 0, and again on dividing 16 by 16 with 2, we get 8, and with the remainder as 0. Here we get the remainder as 1. So while writing the binary number for a decimal number, we write it from the bottom, which is the LHS part. Which is in So we write it by from the bottom to top, which is, and the bottom part is the LSB and the top is MSB. So the decimal, the binary for 65 will be 1 0 0 0 0 1. So here we see that the nibble here is so here the nibble part is 0 0 1 0, and which is the MSB part, and the other side is triple 0 1, which is the LSB part. Now let's see another example. 58, it convert it to binary. So on dividing 58 by 2, you get it as we get it as 29 with a remainder of 0. Now again on dividing 29 by 2, we get 14 with a remainder of 1. Again dividing with 2, seven with the remainder of 0. So after dividing, we get as we get the binary number of 58 as 11010. So now let's see how to convert a binary number to the decimal. So now let's take an example. Let's take this example only. If we take 11010, so here we see that here to convert a binary number to a decimal, we have to you have to follow this principle as this number will be 2 to the power 0, this will be 2 to the power 1, 2 to the power 2, 2 to the power 3, and 2 to the power 4. So on keeping this on the table, so we in the table above we see that it is so on keeping this in the table given here, we see that that 11010 so it falls in this category, that 11010, so it will be 16 plus 8 plus 2, it will be 18 plus 8, 18 plus 8, which is 26. Now let's take another example. 1 1 1 0 1 0. So on keeping it in the above table, we see that we get it as as 32 plus 16 plus 8 plus 2 32 plus 16 plus 8 plus 2. So it would be 42 plus 6, which is 48, plus 10, which is 58. Now let's convert a decimal to octal. So to convert a decimal number to octal number, we have to divide it with 8. So let's take a number 259. Now if we to convert the decimal to octal, we have to divide it by 8. So we get it as 32 with a remainder of 3. Now 32 divided by 8, we get it as 4 with a remainder of 0. So the octal number for this decimal number is 403. Now if we want to convert this octal number to binary, we see we divide first we separate the number 4, 0 and 3. Now a decimal number for 4 is 100, for 0 is 000, for 3 is 011. So the complete binary number for this for number 259 is 100, 000, 011. Now let's take another example, which is 367. Divided by 8. So 367 divided by 8 will be 45 with a remainder of 7. Now 45 divided by 8, the remainder will be 5. So the octal number for this decimal number will be 557. Now if you want to convert this octal number to a decimal, to a binary, first we separate the number 557. So for 5 it is 101. Now for another 5 it is 101. For 7 it is 111. So the complete binary number for the octal number 557 is 1011011111. Now let's convert a decimal number to a hexadecimal. So for this for the hexadecimal, we to convert it, we have to divide it by 16, and hexadecimal is represented as 0 to 9. Then from 10 onwards, it is denoted as A, B, C, D, E, F. So let's convert a number to 287 to a hexadecimal. So 287 divided by 16, we get 17 with a remainder of 15. Now on dividing 17 with 16, we get the remainder as we get 1 with a remainder of 1. So the hexadecimal form for decimal number 287 is 11. Here 15 is denoted by as F. Now to convert it into binary, we have to first separate the number. So 1, 1 and 15, which is F. So for 1 it will be 0 0 0 1. For 1 it will be 0 0 0 1. For 15 it will be 1 1 1 1. So the complete a binary form for the octal number 11F is 0 0 0 1 0 0 0 1 1 1 1 1. On removing the zeros, before 1 we get as 1 0 0 0 1, then 4 ones. So here is the binary format for the hexadecimal number 11F.